In the previous video I showed you how you can get some very simple statistics about the upper and lower limit for a speaker's F0 range. What I want to do now is to show you one way to use that information to make a nice picture. There are other videos showing you how to make more sophisticated pictures than the one I'm going to show you, and actually PRAAT lets you do pretty much anything you want to with pictures. So this isn't the only way to make a good picture, but it's a reasonable way. So the first bit of information that we typically want to know is the minimum F0, so that's around, let's say it's 120 Hertz for this speaker, or at least in this file, and the maximum, which for this speaker in this file is 464.6, so we're going to say that's 465 Hertz. Just make a note of those and write them down. And then we want to know what the average F0 is. Now, this is a bit dodgy because in this case we've only got a very small sample of this speaker, so none of these figures are totally reliable, but the average is going to be particularly unreliable. But we'll just do it for the sake of demonstration. You can take either of these values, either the one that says average in this box here, which is 190.77, or my preferred measure is the median, because the median leaves out some of the more extraordinary values that you might get from a speaker, and over a large sample of data that might be quite important to do. So I'm going to use the median value, which is 172 Hertz. So I've got a note of all of those things. Now let's put the info thing away. I've also produced a label file for this, so if I view and edit these together, I'll just show you. I've labelled it for words, but you could label this for anything you wanted, down to syllables or segments or phrases, whatever. So
Dog there, Mr. Dog. Dog not there, dog.
So the way I've labelled this is just for convenience to show you, but there are other things that you would want to mark. For example, you might want to include the beats that we annotated in a previous demonstration. So let's put that away, and then we're going to concentrate on showing the pitch and the text grid together. So highlight the pitch and the text grid, and then in the PRAAT picture window you can drag to any shape that you want. What I suggest for a pitch trace is that you want a nice long thin horizontal one rather than that kind of more vertical shape. A horizontal shape is a better one. So make the shape the space that you want to dump the picture in, and then click the draw button, and you can see you get lots and lots of different possibilities. I prefer to speckle rather than to draw. I can show you the difference later, but right now I'm going to show you how to speckle, and I prefer to speckle my drawing logarithmically and separately. Separately means it's going to put the labels in one place and the pitch trace in another, and I prefer logarithmic for reasons I explained before, that our perception of pitch is more logarithmic than it is linear. You could also do it using semitones. So if we choose speckle separately and logarithmically, we get another window. Now this is the one where we need the numbers that we just made a record of, because we can decide what the top and the bottom values are going to be. Now, just for the sake of illustration, we're going to make the values a little bit lower and a little bit higher than the ones we measured. So for this speaker we said the lowest value was 120 Hertz. So let's say, just for the sake of illustration, that we'll assume her lowest value is 100 Hertz. The highest value was 465 in this file. Let's assume it's a little bit higher than that, and let's say that she can probably get up to 500 Hertz without too much effort. So what we're doing is scaling this so that when we get the pitch trace, it's going to be roughly within the speaker's upper and lower bounds. And it'll be different from speaker to speaker, so doing it this way lets us see when somebody's speaking high in their range or low in their range, rather than at a particular F0 value, which by itself doesn't really mean very much. Now, you can show the boundaries or not show the boundaries, garnish or don't garnish, and so on, and I'm just going to leave these as they are for now on this picture, but there are other ways to do these drawings. So leave everything as it is, and we'll say OK. And there we've got now this labelled picture with Dag der, Mr. Dag. Dag na der, Dag, however she does it. Now that leaves us with the average value, which we said was around 465 Hertz, and it's sometimes quite useful to show these. Sorry, we said it was 172 Hertz. It's useful to show these sorts of things on the scale, and PRAAT lets you do that. And the way it lets you fiddle with your drawings is by this menu here where it says margins, and you can use margins to do all kinds of things, including adding more numbers to the bottom axis and the top axis. But we're going to add a logarithmic mark, because we've drawn a logarithmic scale, to the left side of the diagram. So we're going to say 1 logarithmic mark, and we want 1 logarithmic mark left. And then the position of this is 172 Hertz, because that's what the average value, the median value was in this particular sample. But we'd rather do that for the whole speaker, so we're just pretending that this value is the value for the speaker. And leave all of these things left here. But it's useful to draw some text here, and the text we can put would be, let's put AVG for average. If we click OK, you can see that PRAAT's added a line. It's actually not very visible because it's superimposed it on top of something else. So I'm going to remedy that by going Command Z to undo it. Instead of sticking it 1 mark to the left, I'll stick 1 logarithmic mark to the right instead. So we want 172 and we want AVG for average, and now this time you should see that that shows up on the right hand side. There you go. Oh, I see what it's done. Now, just to show you what more you can do, you can also put marks on the bottom. So we could put marks on the bottom to show time, and we do say every 1 second. So the distance would be 1. Write the numbers, draw the ticks, but don't draw dotted lines, otherwise you're going to end up with something that looks like a crossword puzzle. And there you go, it's added some stuff there on the margins. So that's the basic sort of technique for drawing F0 contours in a way that lets you show approximately the lowest part of the speaker's range, the highest part of the speaker's range, and a way to mark the average part of the average value of the speaker's F0 on the graph.